Hello, my name is Nick Mowry, and in this video I'll be talking about a project I'm working on to track labor on small to medium-sized farms. The aim with this project is to provide small farmers a way to make data-driven decisions regarding their farming choices. The image shown on the bottom right is the result of searching for labor tracking software and shows just how many other industries already do this. There's a lot of exciting change happening in the agricultural industry right now. Organic produce is ubiquitous, but with its mainstream emergence, prices throughout the value stream have climbed to meet demand. The eager farmer plants accordingly, and to their dismay, harvest does not bring enough to cover the cost of what might be fussier crops or weedier fields. Part of the appeal with chemical weed mitigation is in budgeting. For a given acreage, farmers can easily calculate the herbicide and pesticide required with some simple math. Weed control for the organic farmer requires more labor, but how much is required before the crop becomes unprofitable? The aim of this project is to help the small organic farmer determine where this labor is being applied and evaluate its efficacy. As a benefit, a farmer may want to compare the labor required for two competing methods of planting. For example, soybeans will provide their own weed control when they develop their own canopy of leaves. To this end, a farmer may want to decrease the distance between planted rows. At the end of the season, it may be difficult to detect a 5% difference in labor input from one plot to the other without tracking it explicitly. Alternately, a farmer may go throughout this exercise to find that labor costs and yield are proportionate per plant, but by reducing row spacing by 10%, crop density can be increased without increasing labor or negatively impacting yield. In short, you can't make decisions without options, and options can't be weighed without data. This project aims to provide the data. As this is the preliminary stage of my master's project, I will ultimately be getting data from student farmers working on UMaine's Rogers Farm. Carved out of the woods a few miles northwest of campus, this space is used for a wide range of sustainable agriculture research, extension, and teaching projects. In agriculture, timing is everything. In terms of data collection, my timing kind of stinks. Between only having taken on this project a month or so ago and the abundant rain, there's no current or historical data to develop algorithms or even do rudimentary analysis for the upcoming season. Since data from this location is forthcoming, I began collecting data with some help of my own. We collected several hours of data over a couple weeks on our Android phones using the Gaia GPS app. To get a sense of the phone's ability, I walked the yard with the kids and then sent them off on their own. I made some location polygons to represent distinct areas in the yard. These actual locations in my yard translate loosely to those found on a farm. Here's the raw paths layered over the map. Notice the garden at the top of the image. The paths around the garden were intentionally repeated to evaluate accuracy of the data. Other points, like the cluster to the left, show points made by the children playing on the swing set. And intuition might lead one to think more time was spent in this area, the swing set, because of the point density, but the represented data are a bit misleading. I'm not sure if it's inherent to the hardware or the software, but the GPS data are being collected at a faster rate when the phone is moving. This does provide more resolution to the path, but requires more processing in terms of finding total time spent in each location. The data we collected had suitable precision, but as you can see, they lack accuracy. The images above show the same path traveled 3 times around the garden by me on the left and my son on the right. We followed our tracks within a foot or so, but as the data show, there's a lot of variability in them. This makes it very difficult to determine with which location the points should actually be associated. So what does this mean for the project? A lot of consecutive points were gathered and were quite erratic. So much so that when doing work in one plot, GPS data appear intermittently in neighbor plots. If the phone detects little movement, the time interval between collected points will be greater, thereby skewing the total time recorded for each point. The paths shown here are good examples of this behavior. These data show about 20 minutes of my son swinging on the swing set with my wife's phone in his coat pocket. The points and paths in green show me standing behind him giving him pushes. While the points I collected seem a bit more accurate, they still wouldn't all be included in the location without a healthy buffer. Here at the start of the program, I import the libraries, set local paths, and establish values for the work environment. Also have some debugging logic there. The subroutine simply pops up the open file dialog box and gathers the file name, path, and feature class. Brings it in here, creates a new feature class for the point, and then from there add points to the feature class. Gives a little output on how many points were found, then translates that to a polyline. However, when I tried to add it to the map, I did not have any success. So I downloaded the ArcGIS SDK and started creating a standalone application to import these data files. This is Visual Studio 2017 Community Edition. After downloading and installing the ArcGIS SDK, creating a standalone mapping application now appears in the list of items when creating a new project. It's a little bare bones right now, but with this layout we can add more buttons and text fields and anything else a user might find helpful. Here's the bulk of my code. It prompts the user to open a CSV file, parses the points from it, assigns a random color, and plots them on the map. As I compile the solution, the window appears and we see the map behave as we expect. Clicking this button opens a file. In this case, I've added permissions for opening multiple files so we can dump them all at once. The next phase of this project will be creating a MySQL server so that I can directly import user-recorded paths, query data based on relative geometries, and output maps while being able to provide the user a portal to poke around at the data and run reports themselves. Thank you for your time.